Sample problem 10.6. Calculate the volume of a mole of an ideal gas at room temperature. Room temperature is considered 25 degrees Celsius and 1 atmosphere. Okay? Ideal gas. That means we can use the ideal gas law. An ideal gas is a gas that obeys this particular equation. So P is the pressure of the gas. V is the volume of the gas, or the volume of the container. N is the number of moles of the gas. R is what's called the universal gas constant. And for our purposes, we'll use the value 0.08206 atmosphere liters per Kelvin mole. And T is the temperature. In Kelvin, again, this is a gas problem, so we're going to have that in the absolute temperature of the Kelvin. Okay, so it just says calculate the volume of a mole meaning 1 mole, at a temperature of 25 degrees Celsius and a pressure of 1 atmosphere. Okay, well, volume. PV equals nRT. Divide both sides by P. And P over P is 1. So V is equal to nRT over P. A mole, meaning 1 mole. Gas constant, 0.08206. Atmosphere liters per Kelvin mole. Temperature. Now, let's do the temperature. 25 degrees C plus 273.15 to 98.15 Kelvin. You remember back in chapter 5 when we looked at the standard heats of formation, delta H of formation, and they were all at 25 degrees Celsius or 298 Kelvin. Very common temperature for tabulating data. Divide that by the pressure, 1 atmosphere. I assume when the author does 1 atmosphere and a mole, they're assuming that these are exact numbers. And so looking at this, it actually looks like this one has 4 sig figs, and this one has 5. Now your author might use 298, and then in that case it would be 3 sig figs. Okay? So here's what we get. It's actually a famous numerical result. 1 times 0.08206 times 298.15 divided by 1, and you get 24.47. What are the units going to be? Well, we would expect them to be liters, right? It's the volume. Let's see if we do. Moles and moles cancel. Kelvin and Kelvin cancel. Atmospheres and atmospheres cancel. Liters is the only thing. So there we go. And that is a famous numerical result. What it says is if you have an ideal gas and you have a pressure of 1 atmosphere at 25 degrees Celsius, and it's 1 mole, you're going to get a volume that's around 24 liters. Okay? So how big is that? Well, think of a 2-liter bottle, right? 2-liter bottle, you're going to buy your soft drink, your cola. Three of them would be 6 liters, right? So 24 liters, that would be 12 of them. So you need 12 2-liter bottles. Maybe like a case of 2-liter bottles is going to give you that volume. Okay? Ideal gas law.